Let's start our investigation of calculus by looking at something that I call the velocity problem. So here's the idea. Imagine I'm driving down the highway and I say that at 2 o'clock I'm at the 100-mile marker, but that at 2:15 I'm going to be at the 110-mile marker. So the question is, how fast am I going? But the real question is, what do I mean by how fast am I going? Am I asking how fast am I going at 2 o'clock? Am I asking how fast am I going at 2:15? Am I asking how fast I'm going over this interval? We have to be more precise about what it is that we're asking. One way that we could answer it is by something called the average velocity. So the average velocity is going to be the change in the distance divided out by the change in the time. Or if I want to use a little bit of mathematical notation, I could say that this is delta d for the change in the distance divided by delta t, the change in the time. So let's compute this average velocity over this 15-minute time interval that we have. So if I'm going to come down and try to figure out what the delta d is going to be, well, we went from the 100 to the 110 miles. So it was 110 minus 100, and the units here are going to be miles. And then if I want to investigate the change in time, well, I've gone from 2 o'clock to 2:15, so I'm going to write this as 2:15 minus 2 o'clock. I'm sort of abusing my notation here a little bit, but I can do this computation to say that the difference here is going to be 10 miles divided out by 15 minutes. Now, this answer is actually perfectly acceptable. It's just that we don't typically give speeds in miles per minute. We normally give them in miles per hour. So I can do a little unit conversion here, and I can say that there are going to be 60 minutes inside of 1 hour. And then the minutes are going to cancel. And this is going to be 600 divided by 15. And so this is going to be 40 miles per hour. So this is one way to answer this. This is the average velocity over this 15-minute time interval. Now I'm going to ask a slightly different question. It's, what would a cop measure at exactly 2:15? We had previously decided that the average velocity over this 15 minutes was 40 miles per hour. So how do we answer the question, what is the cop going to tell us the velocity is at 2:15 exactly? Well, we don't know how to answer this question with the amount of information that we have. For example, suppose I was going way faster, I was speeding, but I was speeding only from, say, 2 o'clock until 2:10, and then we hit a traffic light and we slowed down. The cop might not measure us having this higher speed because the average velocity was going to be 40 miles per hour, even though at some point in the middle we'd been traveling way faster than 40 miles per hour, and at some points we were traveling way slower than 40 miles per hour. So this problem, it turns out that we have not enough information. It turns out that there's actually two different concepts here. The one that we had seen before was called the average velocity, and it was over an interval. But what we're really asking here when I say, what is the cop measuring at 2:15 precisely, is something called the instantaneous velocity. And the average velocity over an interval and the instantaneous velocity at one exact time are indeed different things. I'm going to give you a little bit of a different way to think about the instantaneous velocity. Suppose I had a whole chart of information here, and what I want you to note is that what's going on here in this time interval column is that I'm getting smaller and smaller and smaller time intervals. So the first row here is the 2 to the 2:15, but then I do 2:10 to 2:15, 2:14 to 2:15, and I go all the way down until I'm like only a 1 second interval. 2:14 and 59 seconds all the way up to 2:15. So then for each of these time intervals, we know if we have a time interval, we can compute the average velocity. So I'm just going to imagine we've gone and done that, and we've got the 40, 46 going down, and then in this last second here, this one tiny little time interval, it appears that we're going 60 miles per hour over that time interval. Now, if you were a cop and you had this table of data of our different average velocities, do you think that you should be getting a ticket at the 60 miles per hour if you're driving in the city, say? Well, if you only look down here at the bottom at that last second, and you see that this average velocity is the 60 miles per hour, you can be really confident that at the time of 2:15, that you're going to see some speed, which is going to be at least faster than whatever the speed limit is. Something very, very, very close, maybe not exactly, but very close to 60 miles per hour. So this leads me to a notion of a sort of limiting process. If I want to know the instantaneous velocity, that is the velocity exactly at 2:15, then what I'm going to do is look at smaller and smaller and smaller time intervals where the time interval is getting really, really, really close to 2:15. And then you could imagine we could carry on if we had more accurate measurements. This table could carry on going perhaps forever as our intervals got closer and closer and closer to 2:15. And then our average velocities would presumably get closer and closer to some number. So we can think of instantaneous velocity, the velocity exactly at 2:15, to be analogous to the sort of limiting process as these average velocities are done over smaller and smaller and smaller intervals. Indeed, this is effectively how modern LiDAR guns are going to work that police have when they're trying to measure what your speed is. They don't tell you the exact velocity at a specific time exactly. They interpret it as a very close approximation. And the way it works is this, that they can send out this pulse of light and they can figure out what the distance between the cop and the car is going to be. And then some tiny fraction of a second later, another pulse is sent out and they can again get a new reading of where exactly this distance between the cop and the car is going to be. So what you have is a tiny, 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 tiny little interval because the time between these pulses is really small. And then you get a tiny change in distance as well because there hasn't been much change, the car hasn't moved a lot. But nonetheless, you get two distances and two times, and they can compute the average velocity over that interval. And in truth, they send out a whole number of these different pulses really, 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 really quickly, and they can do some sort of average to try to get a very accurate reading. So this computing of average velocities is a very important process for us in the limit as our time intervals get small.